Bismillahirrahmanirrahim. My name is Muhammad Arhanda and I am from BS Chemistry Department. Today my presentation topic is oxidation in organic chemistry. These are the books. With the help of these books, I can make our presentation topic. First of all, I tell you about oxidation. Oxidation is defined as removal of hydrogen, addition of oxygen, and removal of electrons. If these processes are occur in any chemical reaction, then we can say that this process undergo or oxidation reaction. First of all, I tell you about oxidation in different compounds. We can study oxidation in hydrocarbons, in functional groups, and in biomolecules. The hydrocarbons contain alkane, alkene, and alkynes, and the functional groups contain alcohol, phenol, aldehyde, ketone, amine, and the biomolecules carbohydrates, lipids, and fats. These are undergo oxidation process, and the rest of the functional groups cannot go for oxidation process due to many reasons. First of all, I can discuss oxidation in hydrocarbons. We take an alkane. With the help of alkane, we can the alkane undergo combustion, dehydrogenation, cycloalkene, halogenation, isomerization reaction. First of all, I tell you about combustion reaction. When alkane comes to combustion, it produces carbon dioxide and water. Here is an here I take an methane, and this is an oxygen. When methane reacts with oxygen, then it produces carbon dioxide and water. This hydrogen is removed from carbon. That's why we can say that this is an oxidation process. Dehydrogenation, D means removal and hydrogenation means hydrogen. So the complete meaning of dehydrogenation is that the removal of hydrogen. In this process, we remove the hydrogen from alkane and then we get a symmetrical alkane. This is a general process. In general reaction, we remove the hydrogen, and by this way, when we remove hydrogen, then we produce then we get a symmetrical alkane. Here I take an methane. The hydrogen from the methane is removed, and then we obtain a ethane. Here I discuss its mechanism. Uh, the bond, this bond is break, and the radicals are formed. So when these radicals combine, then they produce symmetrical alkane, and when these hydrogen radicals combine, then they produce hydrogen gas. Here I can also discuss example 2,3-dimethyl butane. This carbon and this carbon is called uh, sorry, this is a second carbon and this one is third carbon. So these methyl groups are attached with second and third carbon. That's why its name is 2,3-dimethyl butane. When 2,3-dimethyl butane undergo oxidation in the presence of platinum, when platinum adds its show oxidation process, the carbon from 2 position and carbon from 3 position lose their hydrogen atom. Due to loss of their hydrogen atom, the radicals are present on carbon 2 and 3. And then these radicals are overlapped, then they form a pi bond. So by this way, we can get 2,3-dimethyl-butene. Isomerization. This process is very essential in petroleum industry because with the help of this method, we can convert straight chain into bond chain compound. By this way, we can get high octane gasoline compound. And this process takes place in the presence of heat and acidic catalyst. Here I can quote two examples. This one is an octane, and when an octane undergo a reaction in the presence of acidic catalyst, then it produces 2,2,4 trimethyl pentane. So by this way, we can convert straight chain compound into the branch chain. Cyclohexane. In cyclohexane, the cyclohexane also undergo a oxidation and they convert into methyl chloropentane in the presence of sulfuric acid catalyst. Halogenation. Halogenation means addition of halogens. In this process, CH bond at alpha position of alkyl sulfide. This is a main bond, alpha position. The hydrogen is only removed from alpha carbon. So in this process, the CH at alpha position of alkyl sulfide is replaced by CX bond, where X is halogen or a nitrogen, oxygen, carbon, or sulfur-based constituents. Here I take an example. These are the alkyl and these are alkyl sulfide. This is a functional group. So when alkyl sulfide are directly attached with carbon, and these points show the carbon. So this carbon is called alpha carbon, and the hydrogen attached with this carbon is called alpha hydrogen. So this alpha hydrogen is removed, and the X take place, and the X replace the hydrogen atom, and by this way the hydrogen atom is removed from this compound, and then we get a CX bond. These points show the carbon and this show the halogen. Cycloalkane. Same as cycloalkane produce cycloalkane by the removal of hydrogen atom. All the corners show the carbon, and these carbons contain 2 hydrogens. When these carbons lose one hydrogen, then the radicals are present on all of the on all of the carbon atoms. So these radicals are joined up and they form a double bond. And these radicals are joined and then they form double bond, and we get cyclohexane. Now the oxidation of alkane is finished. Now I can start the oxidation of alkene. Epoxide, combustion, hydroxylation, ozonolysis. All these reactions are occur with the help of alkene. Epoxide. The cyclic compound of oxygen is called epoxide. When we take an alkene in the presence of peroxyacetic acid, it produces epoxide. This one is the cyclic structure. So that's why we can say it is an epoxide. This bond is removed. When this bond is removed, then the radical sign are present on the carbon. So it take an oxygen from for, for oxyacidic acid, and this hydrogen, so these carbons contain oxygen from for oxyacidic acid, and then we get a epoxide compound. Here I take another example. Now we take an cyclohexene in the presence of peroxybenzoic acid. Again, this pi bond is removed, and then the oxygen attached with these carbons. So this cyclic structure is called epoxide, and its another name is oxocyclohexane. Combustion process. The same as alkene also undergo a combustion process, and with the help of combustion we can produce carbon dioxide. We can get carbon dioxide and water. Hydroxidation. It is the single step reaction with the help of KMnO4. This is the cyclohexene, and this is in KMnO4. When these are react, then OH groups are formed. So this process is called hydroxidation. Now the proper understanding of this process, I can write the structure by openly. So this is an open structure of this compound. In this compound, the pi bond is removed. So due to the removal of this pi bond, the hydroxyl groups are attached at this position. By this way, we get this product. So this is also undergo a oxidation reaction, because in this oxygen is attached. Because in this process, oxygen is attached with carbon atom. Ozonolysis. Now we take an alkene in the presence of oxygen. So the alkene in the presence of oxygen, they form this compound. So this compound is highly unstable. So due to the stability, they arrange itself, and then we get a ozonolite. In this compound, the bond is broken. The bond is broken as, and then we get a formaldehyde, and this oxygen react with water, and then we form hydrogen peroxide. So this is also a undergo oxidation reaction. Alkyne. In alkyne, we can discuss combustion reaction, ozonolysis, hydroxidation reaction. First of all, in combustion, it also produces carbon dioxide and water with the removal of these hydrogen atoms. The flame produced from this method is very useful for welding and cutting of metals. Hydroxidation, and this is an ethyne in the presence of oxygen and water, and the potassium permanganate catalyst. It forms this product. So in this product, the two molecules of water, H and OH, these molecules are removed, then we get a glyoxal. So when the glyoxal undergo oxidation in the presence of KMnO4, then we obtain a oxalic acid, because these oxygen is combined with this oxygen is attached at this point. So by this way we can get oxalic acid. Ozonolysis. Same as alkene, alkyne also undergo ozonolysis. This is an acetylene. In the presence of ozone, it forms a product. In the now here we can observe that these two pi bonds are removed. When these two pi bonds are removed, then carbon form two bonds with oxygen by using ozone. So when we in this process, two oxygen is used and one oxygen is remaining. So this remaining oxygen and in the presence of water, they form formic acid. This oxygen is combined with carbon uh, uh, and the hydroxyl group is also attached with this carbon. By this way, we can form two formic acid with the help of these catalysts. Okay, the oxidation of hydrocarbons are enough. Now I can explain the oxidation in functional groups. Alcohols. A primary and secondary alcohol goes to oxidation reaction. This one is an primary alcohol, and when primary alcohol react with oxygen in the presence of this catalyst, then we form aldehyde because the oxidation of primary alcohol produce aldehyde. In alcohols, we can remove a hydrogen atom. When this hydrogen atom is removed, then we obtain when these two hydrogen atom is removed, then we obtain a aldehyde. So the secondary in secondary alcohol, when secondary alcohol react with oxygen, they produce ketone because same as this hydrogen and this hydrogen is removed, when these hydrogen react with oxygen, they form water. So the water is removed and then we get a ketone. But tertiary alcohol do not undergo oxidation reaction because they have no hydrogen which are directly attached with carbon atom. That's why the tertiary alcohol do not undergo a oxidation reaction. Phenol. These are the phenol. When phenol when phenol reacts in the presence of potassium in the presence of sodium dichromate, then we form a phenol. This is a very important reaction, and most of the phenols, when react, they produce phenol by the removal of these hydrogen atoms. And its IUPAC name is cyclohexa 2,5-diene 1,4-diol. This one is carbon 1, carbon 2, carbon 3, carbon 4, 5, and 6. So at carbon 2 and at carbon 5, they form our two bonds. So that's why we can say that 2,5-diene. Di means two and ene means double bond. And at position 1 and 4, dione. On means oxygen. So with the help of IUPAC name, we can easily draw its structure. Here I discuss its mechanism. Uh, Firstly, when phenol react, this hydrogen is removed. When this hydrogen is removed, the negative charge present on the oxygen. After that, the electron removed from the oxygen atom and the radical signs are present on oxygen. The same as again the hydrogen is removed at this position, and when hydrogen is removed, the negative charge also present at this point. So again we remove the electrons, then we remove electrons. These radicals are present and these radicals are highly unstable, so they easily react with bonded with these pi electrons, and then we form quinone because they can attract, these electrons are shifted toward the carbon atom, and these pi electrons are moved at this place. By this way, we can get a quinone. Aldehyde. Oxidation of an aldehyde produces carboxylic acid. When we oxidize the aldehyde, this oxygen is combined with this hydrogen. By this way, we can form carboxylic acid. Ketone. But this same reaction cannot take place ketone because ketone do not have hydrogen atoms that are directly attached with carbon. For example, this hydrogen is directly attached with carbon, so that's why the oxygen is easily attached at this point. But ketone do not have any hydrogen that are not attached with carbon. So that's why we can say that this reaction cannot undergo an oxidation process. Here we take an ketone. Ketone in the presence of KMnO4, they produce this product. Again, when we take an ketone in the presence of peroxyacid or hydro in the presence of peroxyacid, then it produces a ester. So the ketone produce two type of oxidation process with KMnO4 and with H2O2. Amine, aliphatic and aromatic, both amines go to oxidation process. This is an example of aliphatic amine. When we take an methyl amine and when we take an methyl amine in the presence of catalyst, this oxygen is attached in the place of hydrogen. So that so then we can get a nitromethane. Benzyl amine. The same scenario takes place in this process. Also, H2 is removed and the hydrogen is attached at this point. Then we get a benzyl nitrite. We can notice that in this process the oxygen is added. So in the definition of oxidation, I can tell you the addition of oxygen called oxidation process. So these all are the all oxidation process. Uh, Biomolecules. In biomolecules, we also study how the biomolecules undergo oxidation process. First of all, in carbohydrates, glucose undergo excess of oxygen, produce carbon dioxide and water. When glucose reacts with oxygen, in excess of oxygen, then it produces carbon dioxide and water by the removal of hydrogen from this point. Uh, in limit supply of oxygen, when we this is also a structure of glucose, but in limit supply of oxygen and in the presence of H2O2 catalyst, they form gluconic acid, and this hydrogen are attached at this point. Then this formula is called gluconic acid. In carbohydrates, we can take a monosaccharide, not polysaccharide, because the polysaccharides are made up of from monosaccharide sugars. That's why here I can explain only monosaccharides. I can explain the examples of monosaccharides. Protein. Proteins are made up of amino acids. So amino acid is the building block of protein. So we take an glutamic acid, and this is glutamic acid in the presence of the dehydrogenase enzyme. These enzymes have ability to remove the hydrogen atom. These enzymes remove the hydrogen and then we get a double bond. This structure is called amino acid. In the presence of water, these NH react with H2 and then they form NH3 or ammonia, and these oxygen or take place its position. So we can say that this is the formula of alpha ketoglutamic acid, because this is the functional group of ketone. That's why we can say that alpha ketoglutamic acid. And this process is also called oxidation deaminization. How we can say? Because in this process we firstly oxidize the glutamic acid, and in this process the ammonia is removed. That's why this process is called oxidation deamination process. Repeat. Lipids are made up of fatty acids. So here I take a simple fatty acid, glutonic acid. In the presence of coenzyme, the OH group is removed and the coenzyme are attached at this carbon position. So this is called acyl-CoA. Uh, Dehydrogenase enzyme, its have ability to remove the hydrogen. So these hydrogens are removed. Due to the removal of these hydrogens, the double bond is formed. So this is called alpha unsaturated acyl coenzyme. If the hydrogen is removed rather than from this carbon, if hydrogen removes from these two carbons, then we can say that beta unsaturated acyl coenzyme, because this is the functional group. So the carbons which are attached with functional group called alpha carbon, and the hydrogen attached with alpha carbon called alpha hydrogen. Due to the removal of alpha hydrogen, we can say that alpha unsaturated acyl group, and unsaturated due to the presence of these two double bonds. So that's why we can say that this formula is so this is that's why the name of this formula is alpha unsaturated acyl coenzyme. Thanks. That is my thanks. This is from my side.